All right, these are the Geometry 7.4 video notes part 2. So today we are talking more about different theorems that go with the rhombus, rectangle, and square, the specific types of parallelograms, special types. So if you have a rhombus, then one fact about it is its diagonals are perpendicular. What that means is the diagonals, when they intersect perpendicular, means they intersect at a right angle. So that means AC, that diagonal, needs to be perpendicular to BD. All right. The rhombus opposite angles theorem, a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So what that means is, like, if you have AC right here, so AC bisects angle A, meaning it cuts angle A into two equal parts. So that means it bisects angle A and angle C. And then you have, let's switch colors here for this one, this diagonal DB or BD, and it bisects opposite angles B, so it cuts that into two equal parts, and D is cut into two equal parts. Okay. Example 4 says, finding angle measures in a rhombus. So find the measures of the numbered angles in this rhombus. You do not have to find them in order. Okay, so remember that a rhombus is a parallelogram. So the first thing we know is that I know on a rhombus we just learned that the diagonals are perpendicular. So that means the diagonals intersect at a 90-degree angle. So angle 1 is 90 degrees. And the reason why is the diagonals are perpendicular. That was from the rhombus diagonals theorem. Now, I also know that this 61-degree angle is congruent to angle 2. That's because if you picture, like with a transversal, those are alternate interior angles. So that means measure of angle 2 has to be 61 degrees. All right, from there, I know that angle 3 is also congruent to angle 2. The reason for that is we just learned about the rhombus opposite angles theorem, and it said that a diagonal bisects opposite angles. So it cuts this angle A into two equal parts. So that means angle 3 must also equal 61 degrees. All right, and so that means if you add up this whole angle right here, angle A all together, is 122 degrees. So let me see if that helps me. Actually, you know what would be an easier way to do it is to just go with this is 61 degrees, and you have a triangle right here. So if you have 61 degrees plus 90 degrees plus angle 4, that equals 180. So if you do the math on that, angle 4 is 29 degrees. Okay, let's try example B. So same exact thing, we're going to try to figure out the different angles. The first thing I noticed, since they told me it was a rhombus, is that the diagonals are perpendicular, meaning they make a right angle. So angle 3, I'm just going to list them all off here. Angle 3 is 90 degrees because the diagonals are perpendicular by the rhombus diagonals theorem. Okay, another thing, let's see here, that I know is I know that 38 degrees is going to be congruent with this angle. And so that's going to make this whole angle right here be 76. So this angle over here, angle B, is also 76. That means these will also be 38. So angle 1 is going to be 38 degrees. Okay, so then to figure out angles 2 and 4, what I can do is I can think of, let's just do angle 2 first. This is a triangle right here. Let me grab a highlighter and just kind of emphasize that. So this triangle right here, I know that the diagonals are perpendicular. So I know that measure of angle 2 plus 90 degrees plus 38 degrees equals 180 degrees in a triangle. And if I do the math on that, I'm going to find out that angle 2 is 54 degrees. So let's switch colors one more time here. If angle 2 is 54 degrees, so is this angle because the angles are bisected by the diagonals. And then we know the opposite angles are congruent in a parallelogram. And so that means angle 4 is also 52 degrees. 52 also. Did my math wrong there? Okay. Let's go look at this piece of notes right here. So the rectangle diagonals theorem. All right, what the rectangle diagonals theorem says, a parallelogram is a rectangle if and only if its diagonals are congruent. So meaning the length from A to C, so AC is that whole diagonal, has to be congruent to the other diagonal, so D all the way to B. So let's look at identifying your rectangle. You are building a frame for a window. The window will be installed in the opening shown in the diagram. The opening must be a rectangle. Given the measurements in the diagram, can you assume that it is? Okay, so first of all, opposite sides are congruent, but that only tells me it is a parallelogram. And so to be a rectangle, I need to be able to find the length of the diagonal, which I can't because I don't know, for example, that it's a right angle, so I can't use Pythagorean theorem. And if I knew that all 4 were right angles, then I could figure that out. But the best I can do here is that it's a parallelogram. I either need to know that the 4 angles are 90 degrees or be able to show that the diagonals are the same length. Okay, this says you measure the diagonals of the opening. The diagonals are 54.8 inches and 55.3 inches. What can you conclude about the shape of the opening? So we can conclude it is not a rectangle because the diagonals are not congruent. So remember, diagonals, both diagonals must be congruent if it is a rectangle. All right. This example says in this rectangle, so it's already telling us it is a rectangle. QS, which is this diagonal right here, is 5x minus 31. And then it says that RT, which is this diagonal right here, is 2x plus 11. Well, we know that RT must equal QS because since it is a rectangle, we know the diagonals are congruent to each other. So what that lets me do is set 2x plus 11 equal to 5x minus 31. So I'm going to subtract the 2x from both sides. That gets me 11 equals 3x minus 31. I'm going to add 31. That gets me 42 equals 3x. And then I'll divide by 3. So that gives me x equals 14. But they want to know the lengths of the diagonals. So QS is 5 times 14 minus 31, which if we plug in a calculator is 39. And so RT should be the same thing since they are congruent. You could check though by doing 2 times 14 plus 11, which does get us 39, so that's a great check to verify that these are congruent. Okay, example B would be exactly the same, so we're going to go ahead and skip that one. So let's go on down to example 7. It says decide if parallelogram, so this is parallelogram, ABCD with these vertices is a rectangle, a rhombus, or a square. Give all names that apply. All right, so to determine, since we already know it's a parallelogram, to determine if it is a rhombus, we could show that all four sides are congruent. So that would be using the distance formula. To determine if it is a rectangle, we could show that the sides, like the consecutive sides, are perpendicular, meaning we'd show their slopes and show if they were perpendicular. We could also show if the diagonals were congruent. And then a square, it's got to be a rhombus, and it has to be a rectangle. So just for example, if you look at the slope of line AB, that is up 1 over 1, 2, 3, 4. So 1 over 4. And the slope of, let's do AD just next to it. That is 1, 2, 3, 4 over 1. Now, these are not opposite reciprocals or negative reciprocals if you have learned it that way. And so it is not perpendicular, meaning it is not a right angle. So that means it is not a rectangle or a square. So we've ruled out those two. All right, so to prove that it is a rhombus, I could prove all sides are the same length, but honestly, I really don't want to do the distance formula 4 times. But the good news is I could just go ahead and do it for this side, AD. So let's find AD. So remember the distance formula. You have a square root. You do x2 minus x1 squared plus y2 minus y1 squared. And we're going to put that in our calculator. All right, so I got 8.25. So now let's go ahead and let's find the distance of AB. So same thing, we're going to do x1 minus x2 squared plus y1 minus y2 squared. And we're going to put that in our calculator. All right, which I got it is 8.25 also. So what's cool about that is I know that this is roughly 8.25. And so because it's a parallelogram, I know this opposite side is 8.25. Then I know the top side, I calculated the distance was 8.25. And because it's a parallelogram, I know the opposite side of that one is 8.25. So since all 4 sides are congruent, it is a rhombus. Okay, so I went ahead and just drew this one, so if you need to, pause the video and draw in yourself. And so I can look at, are all 4 sides congruent? I can look at, are the sides that are next to each other perpendicular, meaning form right angles? But honestly, the easiest thing to do would probably be to look at the diagonals. So if I know that the diagonals are congruent, that is a rectangle. And if I know that the diagonals are perpendicular, that is a rhombus. So let's first say, are the diagonals perpendicular? So go ahead and find the slope of AC and the slope of DB. Go ahead and pause and do that real quick. Okay, so they are perpendicular because their slopes are negative reciprocals. So right there, since they are perpendicular, that tells me that it is a rhombus. Now let's check the distance of those 2 segments, AC and DB. Use the distance formula real quick. Pause the video and try using the distance formula to calculate this. Okay, so here I calculated the length of the 2 diagonals, and they are congruent, so that means it is also a rectangle. And since it is both a rectangle and a rhombus, that means it is also a square. So square is the most exact name, but technically it is a rectangle, a rhombus, a square, a parallelogram, and a quadrilateral.